Hello students, good morning to one and all. Now presented by Dr. P. Sarita, Assistant Professor, Department of Physics, Government College of Engineering. Now we are going to discuss about the topic laser. This topic as per Anna University Regulation 2021, this Unit 3 consider. Engineering Physics PH 3151 divided into 5 units. This laser topic Unit 3 consider. Unit 3 dealing with accelerations, optics and lasers also. This inside the laser topic contains introduction, principle, characteristics and differentiate ordinary light source and laser light source. Basic component of a laser and population inversion are analyzed. Pumping action, Einstein coefficients of A and B, types of laser and its applications also. And first lecture 1, I explained about the topics introduction, principle, characteristics and differentiate the light sources. Basic component of a laser and its population inversion. What do you mean by laser? Laser stands for light amplification by stimulated emission of radiation. It is a device which emits a powerful monochromatic collimated beam of light source. These light waves from laser source are coherent in nature. It is an artificial light source which exhibits the conventional light source. Laser light emerges as a single narrow beam. It has a travel long distances without loss of intensity and energy. Laser amplifies the light waves. The first laser, ruby laser, was invented by T.H. Meinman in the year 1960. Albert Einstein proposed the theory of stimulated emission in 1917. What are the principles of laser? First one, absorption process. Second one, spontaneous emission. And third one, stimulated emission process occur. First, spontaneous absorption process. We have to consider the two energy levels, E1 and E2. E1 is the ground state energy level, E2 highest energy level. E1 energy level, the number of atoms are presented here. One photon energy instant on this ground state level atom. This one atom absorbed this photon energy. After absorption, this one atoms go to the exit state. That is called spontaneous absorption process. Spontaneous emission process. Exit state atoms are presented here without external energy, without help. Automatically the exit state atoms returns to the ground state timing. One photon light beams are emitted. That is spontaneous emission. Third one, stimulated emission process. Exit state atoms are presented here with the help of external energy. For example, one photon energy instant on this one atom. This one atom returns timing. Two photon light beams are emitted. Suppose two photon energy instant on this two atoms return timing, four photon energies are emitted. This is four photons for multiplication of light beams are emitted. That is laser beam. So overall conclusion, this laser beam producing only stimulated emission process occur. With the help of external energy. E equal to h photon energy instant on this exit state energy level. This exit state energy level atom absorbed after this emission of the light beams produces. The absorbed atoms return timing, two photon beams are emitted. Two photons are instant after four photon light beams are emitted. Three photon energy instant after. The three photon atoms returns to the ground state timing. 6 photon light beams are emitted. This multiplication of photon beams are emitted. That is multiplication of chain reaction amplified the light signal occur. Therefore, This finally, this multiplication of the light beams, that is for laser beam. So conclusion, this laser principle, absorption laser principle diagram, and spontaneous emission and stimulated emission process diagram. This absorption process, okay, this was one photon energy instant after absorption, go to the exit state, and then exit state atoms return timing, one photon energy emitted without help of the energy. And third, stimulated emission process, exit state atoms, one photon energy absorbed after this atoms return timing, two photon light beams are emitted. Okay, therefore H nu, E equal to H nu, that is equal to E2 minus E1. Difference between the exit state energy level to the ground state energy level. And next, characteristics of laser. 4 important characteristics are analyzed. First one, high directionality. Second one, high intensity, highly monochromatic of the light beams. And fourth one, highly coherent beam. Explain the directionality. This diagram for consider the ordinary light source. This is compare that laser light beam. Ordinary light source for spreading in all directions inside the wall, but this intensity is very less. Directionality is for spreading in all directions, but this is for 1 meter per meter. This compare that laser source for highly directionality. This is a single narrow beam. The single light beams for instant on this wall. So high long distance instant on this light source. This is a laser beam, red color laser light sources. This wavelength for high, the 6000 Armstrong to 8000 Armstrongs for producers. This laser beam angular spread is 1 millimeter per meter. Next properties, intensity. Compare this laser light source. Okay, this is a single narrow beam light source. Okay, this light source is for example, this is ordinary light source spreading in all directions. This is a laser source. This instant on this wall, this surrounding this surface area. This laser source high intensity region. The spot is for large. The single narrow beam for using long haul and short haul communication process occur. For example, 1 milliwatt power helium neon laser produces, that is its output for greater than the sunlight source. Third property is monochromatic. This for you can optical properties of the materials. The optical property light source instant after. Okay, you can diffraction of the color beams are analyzed. For example, this is prism consider. Okay, one edge you go to apply this for monochromatic light source, mercury vapor lamp incident after. This diffracted light beams are analyzed with GR. These suppose you have to apply this laser beam applied. This is single narrow light beams. This peak is for highest maximum intensity occur. This wavelength is high. Okay, this is a broad wavelength. This is a broad intensity line. That is ordinary monochromatic light source. The single peak of highest peak intensity consider the laser beam. Okay, this is 1 nanometer laser beams for consider this peak. This peak for your monochromatic light source. This is differentiated. This initial to final. This range are calculated. Sorry, you have to calculate for example 100 nanometer to 300 nanometer for analyzed. Coherence beam. Coherence meaning same amplitude, same frequency, same in phase occur. So your laser beams for single narrow beam. The single narrow beam, you could analyze the waveform. Same node and antinode waves. This phase also same, frequency also same, amplitude also same. With this are you have to consider this for coherent light source. Can compare that ordinary light source, for example incandescent light source, spreading in all directions. This all direction producing the light beams wave, so not coherent beam. Okay, not same in frequency, not same in phase, not same in amplitude. Node and antinode waves for varied. That is incoherent light source. Comparison this ordinary and laser light beams. The first one, ordinary light, the angular spread is more. Laser beams for angular spread is less. There are not directional. We are not consider the particular direction. Laser beams are highly directionality. This intensity is very less, ordinary light source, and laser beam intensity is high. Coherent, this ordinary light source does not a coherent beam and not in phase. Laser source for coherent beam and in same phase, same frequency occur. Ordinary light source radiation are polychromatic, radiations are monochromatic for laser beam. For example, for ordinary light source, sunlight, mercury vapor lamp. Laser source example, helium neon, carbon dioxide or semiconductor diode laser also. Next topic, basic component of a laser beam. Production of the laser beam, we go to consider the major three components. First one, active medium or material considered, or active center. Which material you go to consider, that is active medium. For example, helium neon laser using the helium neon, that is active medium. Pumping source is the second component. The pumping source, depending where atoms for atoms are presented in the exit state energy levels and then ground state energy levels are calculated. The pumping source, depending what population inversions are analyzed. The pumping source, there are 4 methods are calculated. And the third one, optical resonator. I am briefly explain this next each content. Basic component of a laser, the pumping source, that is a population inversion is achieved. Population inversion meaning exit state atoms is higher, ground state atoms is very less. Can compare the E1 and E2. Number of atoms presented in the exit state level N2 is greater than N1. This N1 is the number of atoms presented in the ground state level. This N2 is greater than N1 timing only, population inversion is achieved. By your pumping source acting in this material, this exit state atoms return timing, laser sources are emitted. Next, active medium or active center. We go to consider this material. The material we go to center of the position of the devices. Center of the position of the devices. Okay, this medium may be made up of solid or liquid or gas molecules are considered. Okay, this active medium, okay, inside this any container or any Coolidge tube or xenon flash tube, any optical material inside this active material are considered. Next, the active medium after population inversion achieved after or material for acting. So active center. Third one, optical resonator, that is resonant cavity. Resonant cavity meaning what consists of a 2 optical reflecting mirror or reflecting surfaces are considered. One mirror for 100% highly reflecting mirror, another 150% partially reflecting mirror. This both end your production of the laser beam, okay, your material instrument devices, both side you have to consider this for 2 reflecting mirror, one for R1 and another for R2 reflecting mirror. Consider this in between the reflecting mirror center, you got to consider the active medium. Okay, this active medium outer surface of R, you got to consider the pumping actions. You got to using these sources, light sources using pumping action. Xenon or krypton flash tube also using. Okay, this output for only producing partially reflecting mirror only used, not 100% reflecting mirror. This left hand side mirror, okay, not producing the laser beam. Only your laser devices or output laser beam producing only 50% partially reflecting mirror. Next, pumping action is an essential requirement for producing the laser beam. What are the methods for pumping action? Okay, first one, optical pumping. This output excitation by photons. Second one, electrical discharge method, excitation by electrons emitted. Third one, direct conversion method. And fourth one, inelastic collision between the two atoms. Optical pumping. The atoms are excited with the help of photon energy. Instant after, these light beams are emitted by an external optical source. The atom absorbs this photon energy. The photon energy absorbed after these atoms go to the exit state. That is a pumping action. So before pumping, this is after pumping. Before absorption, that is after absorption. Not automatically go to the exit state. We go to some of the external energy instant. Okay, pumping this material. So this material absorb this energy, photon energy absorbed after, go to the exit state energy level. For example, ruby laser using NDO-AG laser devices, xenon flash lamp is used as optical Coolidge optical tube pumping method analyzed. Direct discharge method. Second one, direct discharge method. Okay, this direct discharge method, electrical discharge tube using electrons are produced. The electrons are accelerated to very high velocity by applying a strong electric field depending, and the electron collide with gas atoms and those atoms are raised to exit state. For example, carbon dioxide laser, argon laser. This direct discharge method, inelastic collision between the two atoms. There are two atoms are considered. One atom A, another atom B. This A atoms, one electron observed. This one electron observed in the ground state energy level. This A atoms observed after A go to the exit state energy level, and some of the electrons returns to the ground state. And then second one, B atoms in the ground state level, A in the exit state energy level. This A atoms and B atoms are collide. Inelastic collision between the two atoms. This A asterisk plus B, one electron observed after, B go to the exit state energy level, plus remaining A atoms returns to the ground state timing. That is inelastic collision between the two atoms. For example, this were exit state energy level atoms. This is spontaneous emission. This is A, go to the exit state level, A plus E. A go to the exit state level. Okay, A asterisk here. This A asterisk for return. The A asterisk return to the ground state level. A asterisk plus B. Okay, the B atom observed after. B go to the exit state level. A returns to the ground state level. That is inelastic collision between the two atoms, or transition between the two atoms. And fourth one, direct conversion method. That is electrical energy's conversion to the light energy. Using the diode. For semiconducting diode materials are used. Okay, this is a direct banding of semiconductor used due to the electrons and holes recombinations are analyzed. The electrical energy is conversion to the light energies are directly produces. Okay, that is example semiconductor light sources. Next, pumping action definition. It is the process of supplying energy to the laser medium to achieve a state of population inversion. Optical resonator constitutes an active medium kept in between a 100% reflecting mirror and a partially reflecting mirror. The optical resonator for, we have to consider the both the ends. One end is for acting in the 100% reflecting mirror, another end for partially reflecting mirror. And third one, population inversion. The state of achieving more number of atoms in higher energy states than that of lower energy states. That is N2 is greater than N1 is known as population inversion. And finally, I have concluded that population inversion. So it creates a situation, the number of atoms in the higher energy states is more than that of the lower energy states. Okay, N2 is greater than N1. Okay, this condition occurred timing. This pumping action for easily analyzed. The atoms are returned exit state to the ground state return timing. Laser beams are emitted. That's all. Thank you one and all.